This is a demonstration of the automatic lawn cleaning system designed for you by Team 21. After our last discussion, we have updated our design to incorporate your new requirements, mainly the need for a graphical user interface so as to easily follow the simulation run, the ability of lawn mowers to communicate with each other and cooperate to clean the lawn faster, limited energy for each lawn mower and the existence of charging pads where the lawn mowers can recharge. Today, we will briefly go over the design of the final simulation system with these new requirements incorporated. We will also talk a little about the implementation details of the various components and then spend a few minutes demonstrating the system and its capabilities. As you can see, the overall design of the system is the same simple and intuitive one as the prototype. There are 4 main classes that divide the responsibilities of maintaining and executing the simulation between them. The simulation is driven and coordinated by the singleton simulator class. The object of this class is the one that is responsible for setting up the simulation environment, providing correct information to the lawn mowers, and ensuring that all mowers behave according to the constraints of the environment. As the central coordinator, it is also responsible for passing data between lawn mowers as they attempt to communicate. In order to do all this, it maintains the information pertaining to each lawn mower status in a separate class called simulation mower. Through this class, the simulation system keeps track of information such as the energy of each mower and whether the lawn mower is stalled, active, or crashed. Keeping this information in a separate object ensures that the lawn mower cannot access or modify it even if it wished to cheat. The lawn mower class is used to store information relating to the mower's business logic. Each lawn mower uses this information to make decisions about its future movements and communicate this information to other lawn mowers. Finally, we have the lawn class. This class stores all information about the lawn layout, such as the locations of the mowers, grass, and craters in the lawn. It also provides methods that the simulator class can use to provide relevant information to the lawn mowers. The same lawn class is used by each lawn mower to maintain its current understanding of the lawn, and hence it also has methods that lawn mowers can use to facilitate their decision-making process. The application is structured as a simple, lightweight web application. This allows for a lot of flexibility in designing the user interface and allows for the system to be very easy to install and execute. The entire business logic is hidden behind a REST server running Spring Boot. The user interface is an intuitive web interface through which the user can interact easily and conveniently with the system. As the simulation progresses, the system sends its current state to the user interface and it is displayed to the user in an easily understandable manner. The simulation system begins by asking the user to upload a file containing the initial state of the simulation in the agreed format. The user can choose any file on the client system and upload it. Once the file is uploaded, the system sets up the entire simulation environment in the background and renders the current state for the user. Each element shown is very easy to understand. You can see each mower labeled with its ID, the uncut grass, and the various craters. Energy pads are shown simply as yellow squares. Simulation statistics are shown in a separate box on the left. These include the size of the lawn, the amount of grass on it originally, the amount of grass that has been cut, the number of turns of the simulation that have passed, and so on. Clicking on a mower displays various statistics about the mower, such as how much energy it has remaining, whether it is stalled, and so on. Any mower that crashes is simply removed from the screen. The user now has the choice to press the next button and watch the simulation progress one step at a time. At each step, a new mower is polled for its action. The action is carried out and any visible changes are displayed. The user can also, alternatively, click on the fast forward button. This will immediately execute the entire simulation until either all grass is cut, all mowers are incapacitated, or no more turns remain. At this point, the user can see the final statistics of the lawn as well as the final status of each individual mower. The user can also stop the simulation at any point and upload a new file. We will now run the simulation on a large lawn with no craters on it to demonstrate the basic strategy the lawn mowers follow. As you can see, each mower sets off from its initial position, exploring the environment through scan actions and progressively cutting the grass. This continues as long as the mower has enough energy to do so. During this process, each mower is careful to avoid craters and other mowers. Each mower also broadcasts the information it receives in scan actions as well as its own movements to other mowers. Whenever a mower sees another mower in its scan results, it adds the new mower into its understanding of the lawn and tracks the locations of the new mower from that point on. This allows the lawn mowers to pool the information they have obtained about the lawn and save energy. Eventually, the mower detects that it has started to run out of energy. When the energy level reduces below about 25%, the mower stops exploring and heads towards the nearest energy pad. It recharges itself, moves to the nearest uncut grass it knows about, and then continues exploring the lawn around that point. This process is repeated until the entire lawn is free of grass. We at Team 21 are a small group of passionate software engineers dedicated to solving all your software related needs. Our team consists of Sujay Bothe, Malarvizhi Vasudevan, and myself, Vipluv Shetty. We hope you enjoyed our demonstration today and love our simulation system. It has been a pleasure working with you, and we look forward to making many more such well-architected solutions for your needs. Thank you and have a good day.